Hi, I'm Nagib Nadir, and I'm from Indonesia, and I'm currently studying at UIN Datokarama Palu or University Islam Negeri Datokarama Palu. And today, I'll be showcasing you, or maybe tell you, the basics of the poop course, or Python object-oriented programming. So, what is that exactly? Well, I know how to use Python, but what is an object-oriented programming mean? Well, think of it as your room. Your room can have many objects, sort of like your chair, your monitor, your PC, your plugs maybe, your cups, your boxes, and many other things. An object is like a bundle of related attributes, or maybe so like phone, a cup, or a book. And methods like functions that you need a class to create many objects. And a class is sort of like a blueprint that used to design the structure and layouts of an object. And think of it as your phone. Your phone has many attributes, sort of like what model is it? What type of OS is it using? And does it have an OLED screen? And can it cure my depression? Well, that can be a Boolean, true or false, but yeah, functions. Functions. Think of it as an action that you can use for your object. For instance, like your phone. Can your phone be turned on? Can your phone be turned off? Can it receive some calls? Can it make text or maybe text someone? That is, functions and variables. Think of it as an attribute and a function for the object. And almost everything, and I mean everything in Python, is an object with its variable and methods. A class is like an object constructor or a blueprint for creating and describing some objects. In the topics of this video, I'll be discussing about variable, method, class, and object, inheritance, encapsulations, and setter and getter. I'll be using timestamps in this video so you can just skip right into the tutorial. And for the get-go, don't think my video is going to help you understand more complex type of object-oriented programming. I suggest you watch some other great videos that other programmers do, like Bro Code or maybe Harvard University YouTube. I suggest you go learn that, and rather me talking about this PowerPoint presentation. And without further ado, sit back, relax, and enjoy. Hi, and welcome back to my video. Today we're going to discuss about objects and classes in Python object-oriented programming. So, first of all, what is an object? An object is sort of like a bundle of related attributes or variables and methods or functions. And such, your objects. Sort of like in your room. Your room has many objects. Your phone, your mic, your keyboard, your monitor, your chair, your controller. Anything can be an object as long it's in real life or maybe in digital. So, in my case, my phone, does my phone have what type of model am I using? What type of OS am I using? And does it have an OLED screen? And can cure depression? And a book, does it have an author? How many pages does it have? And what type of book is it? What type of genre is it? And such, you need a class to create those objects. So what is a class? A class is sort of like how you want to design and structure and sort of like the layout of your chosen object. And such, let's go ahead and write the code. So first of all, we're going to use the class to make our blueprint. My blueprint is going to tell me about my phone. So first of all, when you create a class, you're going to use an init. This is sort of like an initialize def or function to initialize one of the core blueprints or attributes for my object. So we're going to use this self. This self is going to represent as a way to initialize your parameter or object and a way to access your variables and methods. Think of it as that way. After that, we're going to use, or we're going to call our blueprint, or we're going to make our blueprint. My phone has a model, an OS, and we're going to use a boolean in this one. Is OLED. So it's going to, so this question can be a true or false thing, and can it can cure depression. And then we're going to use this self to initialize or maybe call a model OS or maybe this parameter. And such, we're going to use self dot model equals to the parameter we're going to use, and then we're going to repeat it until all of this parameter is called by a self parameter. And such, we're done. We've created our own blueprint for our own object. Now, after that, we're going to insert a type of data in this model, in this or in the parameter. So, how are we going to do that? We're going to create another variable outside of our class and call it phone, maybe. We're going to get our class, sort of like my phone, and then the model and the OS and is OLED and can cure depression. We're going to call them. So, what type of model am I using? My model is Realme, for instance. Realme, and then the type of OS. I mean, I'm currently using Android. And the OLED, is it OLED or not? I'm going to call that false because my screen isn't OLED. And can it cure depression? Well, of course, false. Now, in order to call this, we're going to use the print method, and then, well, not print method, it's sort of like, well, you get the point. We're going to use print, and then we're going to call the parameter that we just used to insert our values, and then use the dot operator to access this init function, init function, and to access the model, the OS, and is OLED, and well, all the attributes that we've created. So if we call phone.model, we're gonna get, well, Realme. If we call phone.os, we're going to call our Android. And well, that's it. You've successfully created an attribute for your object. And such, how do I create a function or maybe a method for my phone? So we're going to use a def function and use turns on. This method is sort of like an action that your object can do. So my phone can be turned on and turned off after this. Oh, don't put self in here. And then use print. I'm going to use an F string here. This self dot model. So this Realme is turned on, and then when I turn it off, it's gonna say off. It's gonna say this Realme is turned off. Such, How do we call this function to work for my print? It's the same as when you call a normal function, when you need to call its name first. But when using an object-oriented programming, or when it's in a class function, you need to use your phone that has the value of the attributes, and then you're going to call the name of the methods that you're going to use. So in my case, it's turns on, and don't forget to use this uh, sort of parentheses. And when I run this file, it's going to call this realme is turned on. As you can see, this realme is turned on. This none is, well, you can just use this. You can just use this when you want. See, this realme is turned on. So when you get this type of error, or not an error, type of output, you can just get rid of the print and then just access the def function while not using a print. You're done. You've successfully created an object. The object has an attribute. The object has methods. And the object has values that you can call it. So a bundle is related attributes or variables, and methods that can be a phone, a cup, a book, or something else that you need a class to create many objects. This blueprint or this class is used to design or structure a layout of an object, and that's all. I hope this video helps you in your, well, journey for learning Python or something else. And yeah, see you in the next chapter. Hi, welcome back. And today we're going to talk about inheritance. Inheritance, well, think about it as a parent and a child, where the parent, if the parent has a braided hair, then the child may have a braided hair. And if the father has a straight hair, then one of the children has a straight hair. So the child inherited the hair by his parents or her parents. An inheritance allows a class to take or inherit attributes and methods from another class. And one of the key uses of inheritance is called super. This allows you to extend the functionality of the inherited method, like so. Let's say we'll create a class called cat, def and dunder in it, and then in the cat method, we're going to have the cat's name, can eat, and can sleep. And she can has 9 lives, has 9 lives now. And we're going to make another class that's almost the same but different animal, and such a dog. A dog can have a name, a dog can eat, a dog can sleep, and the dog can be loyal. And we're going to change into loyal. And well, let's say we have a 2 classes that has almost the same attributes that we're going to use. This is where inheritance is going to be useful. We're going to change and remove this from the classes cat and dog, and we're going to create a object that represents them. What represents a cat and a dog? Well, they're animals. So we're going to make a animal class that takes the def and init, thunder init, and then we're gonna take all of the attributes that has the same meaning to it, and such. The dog can sleep, and the dog can sleep, and the cat can sleep too. All of these are the same, so we're gonna put them in the animal class here. Going to change this into name, can eat, and can sleep. Now, after that, think of this animal as their parent, and the cat and the dog is their child. The child will inherit all of their parents' attributes and then make it their own. The reason why we choose this is to remove redundancy in a code, because if we put in, well, a lot of this, well, it's gonna be a lot of changing to do. Like so. A cat equals cat, and then we're going to choose what's the name for a cat? That's good. Alex maybe? And then can the cat eat? True. Can the cat sleep? True. The cat has 9 lives? True. And then the dog is equals to dog. What's the dog's name? Douglas. I don't know. Can the dog eat? It's true. Can the cat can the dog sleep? True. Is the dog loyal? True. If we create let's say, a method for a cat and such, def eat, and then self, print f string, and then the self dot name is eating, and then def sleep. Of course, an animal can sleep, right? Sleep, self, print f string, self dot name, and then is sleeping and such. If we create the cat and we want the animal to, well, activate an action, we have to copy this and paste this again and again. Well, if you have just 2 or maybe 3 or maybe 4 functions and attributes, that won't be a problem. But if you have many or multiple classes in one code, that can be a problem. And as a consequence, you have to change, well, let's say I change sleeping into drooling, or drooling. I have to change that in all of my coding. So it will be redundant, and, well, it's tiring for if we do that. So we're going to take this, all of it, and just put them right into animal, because this cat or animal can sleep and can eat. Can a dog sleep and eat? Of course, they can eat and sleep because it's a living being. And then, because the animal has the name attribute, can eat attribute, and can sleep attribute, we're gonna get rid of all of this, and we're gonna use the super method. Now, the super method we're gonna use is like this. We're gonna just use in right on the bottom of the def or the definition. We're just gonna use super and uh, parentheses, and it's just use dot, and after dot we're going to, well, uh, inherit the parent class that we're gonna use, which is animal. We're gonna use init, and then what type of attributes that we're going to inherit. I'm going to inherit name, and the can eat, and can, oh, and the can sleep. Now, as you can see from before, we have the can sleep and can eat, and name won't, well, darken. And now it's lit up because we're going to use this these parameters from the attributes that we've taken from the animal class or the parent class that we're going to use. We're just going to copy this again and put this here, and done. And such, if we use cat dot eat method, at eat, and then use this. And then after that, we're going to take the class animal because the parent is on that. We're going to write on the end of cat is parentheses and add animal. And such, we've inherited the animal on the initialize or init function. So we can get the attributes for the name of the animal, can the animal eat or not, and can the animal sleep or not, and also the function if we were going to use it. I'm going to use this animal too. Save, and then we're going to call cat. We're going to test it. We're going to try the print method and try cat dot name, and then print dog dot name. So let's try it. Oop. And then we got it. We got Alex and Douglas. What if I try the method of the name? So cat sleep and the dog eat. Oop. Oh, I'm sorry. I forgot the set of parentheses after we're going to use a def function. Remember to use that. I forgot. And we're going to remove this print files. So we got the don't get the output none after the these output as given. So let's try it again. And there we go. We successfully created a inheritance file or inheritance folder or inheritance try. So inheritance allows a class to take or inherit attributes and methods from, well, another class. For example, the animal is a parent and the cat and the dog is like the child. They take and inherit some attributes from the parent child. Add the parent's class from another class. Allows you to extend the functionality of inherited methods, and that is the super method. So that's it for the inheritance, and I hope you get what I'm saying. I'm sorry if I'm a little bit nervous because I usually don't talk about English. I'm sort of try to train my English while coding, and I hope this tutorial about inheritance helps you on your journey. And see you on the next page. Hi, and welcome back to another video. This time, we're going to, well, discuss about what is encapsulation in Python, object-oriented programming. So, encapsulation. It describes an idea of how wrapping a data and methods that work on a data within one unit. This puts restrictions on accessing variables and methods directly and can prevent the accidental modification of a certain data within a class. There are two types of encapsulation, which is private member, which uses 2 underscores, and protected members, which uses 1 underscore. The members of the class can not be accessed outside of the class, but can be accessed from within the class. Or, well, you use subclasses. And private members are only accessible within the class where they are declared. So, for example, let's say I'm going to, well, create a payment class, and then we're going to put an init here, and this functions as a price indicator. So, self dot final price is equal to price plus price and times, where are the times? 0.5 for the heck of it. And then we're going to call this one payment, a new variable, and then call this class payment, and then we're going to, well, pick the price. Let's say $10. And then what happens if someone that you don't know, not your friend, not your family, but someone random, choose to, well, change your configuration here? Let's say I'm the stranger that was going to change your configuration. So payment dot final price. Final price is equal to 0. Oh, I forgot to final price equal to 0. So before, our price is 10, but now it's becoming 0 because someone changed it. So when I go ahead and print the variable here, payment dot final price, is, when I try to run it, it's going to say 0. I hate that. I want to change that. So I choose the private method. In such, we're going to use the double underscore here on our attribute that calls, this means it's private, so it can be accessed within the class that they are declared in. So the payment here, we're going to choose double underscore here. And now we're going to, well, payment dot get here. After that, we're going to make a function that uses the get method. This get method, well, think of it as a way to take something from a variable that's privated, and, well, return the value from the function. So, for example, like get final price, and then self, and then use return. I'm just going to return the final price of the first def function. Return self dot double underscore and final price. And then we're going to get rid of this. Get final price. Don't forget the parentheses. And then what this means, that although someone was trying to change our code, but now I've privated my member. I've privated my def function, so it will not be editable from someone I don't know or a stranger I don't know. So when I run this, it equals to 15.0 because although they change it, we use the get function and then the private member. So this 0 means you're probably thinking, hey, how do I change this? Do I have to change this again and then choose price and then times price again and then times price again? So it made different from outputs? No, you can just use the set method, the set final price self. This set is this function as a way to, well, edit your function. So let's say this output, I wanted to put a discount on my output. So I just choose discount, and then we're going to call this self._, and then we're going to choose final price. This equals to self dot final, I forgot the double underscore, final price, minus the self dot double underscore final price, and times the discount that we're going to choose. Discount, doing this. Now, what this is going to do is, well, set the value from before, and then add a discount from it. That's going to, well, edit your value from before. So before, it's going to choose price plus price times 0.5, but now it's going to choose your final price value, this value, and then minus it into the self final price times the discount divided by 100. So it's going to choose the total discount. Now we're going to choose the final price or the discount of it. So we're going to payment.set underscore final price. That equals to, well, let's say 5. We're going to get rid of that and then get final price. Let's see what happens. And as you can see, it divided by 15.0 to 14.25. Then let's say we put a private member to a def function. So let's say def, I want to put another calculate function on my payment class. So calculate a discount, and don't forget the double underscore method to private this method, and then use self dot discount, not dot, comma discount, and then we're going to choose this, and we're going to return what's on, well, the final price here. And so to pick up this, we're going to paste that, we're going to get rid of this, and then, well, we're going to minus it into a self dot double underscore calculate discount, and then we're going to pick up our parameter here, so well, error, and discount. Oop, not that. Discount. And then what this does is I've just put a method here that's private, so none other than me can edit it, or someone who actually knows the code can edit. So when I run this, it's going to, well, hopefully normal. Yep, it's still normal. It's for like before. But when we try to, well, change the calculate that calculate payment, I forgot, payment gas and set, oh no, calculate, oh I forgot the dot, calculate discount, and then we're going to change the discount into, well, 100, let's say. When I choose this, that's going to, yep, let's say payment object has no attribute, calculate you mean by payment, and calculate discount. That's, well, typically they're saying, hey, this is a private member. I think you can't access this. So you have to know the full method from it, I guess. So, in conclusion, encapsulation, it describes an idea of how wrapping a data, and the methods that work on a data within one unit, which is payment. This puts restriction on accessing variables and methods directly and can prevent accidental modification of a certain data. So there are two types of encapsulation. There are protected and private. To get the privated or protected members, use the get method, and to edit the protected and private members, use set function. So that's the conclusion of my video, and I hope you, well, I'm sorry if my English is very, very what do I say, not well enough to describe things from my perspective. I usually use Indonesia to describe something, but hey, at least I try. So thank you all so much for your participation and your, well, your views, I guess. Thank you so much, and I hope this is helpful to you for your journey from to Python object-oriented programming. And yeah, see you all on, well, the next video or something. Goodbye.